Welcome to this lesson on matrix operations designed to help beginners understand the critical role that it plays for data science, especially for machine learning, whether supervised or unsupervised. Well, how do you work this in Excel using matrices instead of the method of substitution? So you have these three equations in three unknowns, and we can write this in matrix notation as such. With this notation, we are now ready to solve this problem using matrix operations. So at the end of this course, you should be able to work this kind of simple matrix problems using Excel for solving systems of equations like this problem of three equations in three unknowns. Later on, we will do basic ordinary least squares regression plus understand matrices for future discussions in investment analysis and modern portfolio theory, multivariate regression, and unsupervised machine learning. First up, what is a matrix? A matrix is a rectangular array of numbers arranged in rows and columns. Then there's the order of a matrix m by n, which notation-wise means there are m rows and n columns. Moving on to types of matrices, we have the row matrix with one row and multiple columns, also known as the row vector. For example, the first row in isolation of the previous matrix can be thought of as a row vector. A column matrix, one column, multiple rows, also known as a column vector. For example, the column on the right can be thought of as a column vector. Square matrix, where you have the same number of rows and columns. In our previous example, the matrix is actually a square matrix. Then you have the identity matrix with the diagonal elements all are 1, and then all the other numbers on the off diagonal are 0, like so. Matrix operations. For addition and subtraction of matrices, the matrices should have the same order, meaning they should both be m by n. If you have two matrices A and B, they should have the same rows and columns to do the addition or subtraction between the two. Notice that it's just addition or subtraction between the same positions in both matrices. So it's nothing different from working with spreadsheets with the same sizes of the cells for both A and B. Scalar multiplication, when a constant is multiplied to each element of a matrix. When a constant is used to multiply a matrix, it is known as a scalar. In matrix literature, it's just a constant number and it just scales up or down all the numbers within a matrix on which it is multiplied to by that constant. In this example below, 2 is the scalar. So it's just a constant multiplied to the matrix. Matrix multiplication, where you have to do row by column multiplication. Okay, when two matrices are multiplied to each other, we need to remember a few things. Number one, matrix A multiplied by matrix B can only happen if A is m by n and B is n by p. The resulting matrix C is m by p. Number two, matrix multiplication is not commutative. AB is not the same as BA. So care must be taken about which matrix is at the left and which is at the right. The actual resulting multiplication is quite tedious when done by hand, and we will only demonstrate it here. In practice, this is where spreadsheets and other kinds of software are actually very handy to do this versus manually computing. In MS Excel, we use the mmult function to multiply two matrices. Now, depending on your version of Excel, the output might be in matrix format that is either observable in the spreadsheet, at least for newer versions of MS Office, or it could all be put in one cell only, which has to be expanded by highlighting the size of the resulting matrix with the cell in the left top corner, highlighting the resulting matrix expected, then pressing Ctrl-Shift-Enter simultaneously. Now, for those whose Excel version doesn't show the entire matrix in the worksheet, Please feel free to download the QuantProf Basics add-in in the website for easier matrix operations. We shall have a demonstration later on. So this is what matrix multiplication looks like. You have matrix A, the first row, multiplied by matrix B, the column, and then that'll be your element in matrix C, and so on and so forth. Now again, we will not do this individually, but we will rely on the spreadsheet to do the final computations. In the spreadsheet, it becomes very straightforward when using MS Excel, as we simply use the mmult function as discussed a while ago. So we have matrix A times matrix B is equal to matrix C, and if we reverse the order, matrix B multiplied by matrix A, you'll notice that it'll come up with a matrix D, which is different from matrix C. Again, matrix multiplication is not commutative, so AB is not the same as BA. So pay attention to the order of the operations. The transpose of a matrix, where you swap rows and columns. So if the matrix is initially M by N, then transposing it, it becomes N by M. And it's very straightforward to apply in a spreadsheet. Determinants and inverse. For this part of the lessons, we shall simply rely on working problems via Excel, as the whole process of getting the solution is very involved and done by hand. Since we shall be relying on MS Excel anyway, we shall dispense with the how-tos and go straight to the applications. When solving 3 equations and 3 unknowns, as in the given example, we will have to find the inverse of the given matrix. Why? Because the solution requires finding a multiplicative inverse. That is, finding a matrix that when multiplied to the original matrix gives an identity matrix. Say what? Okay, well, a simpler explanation is in order. In this example, 2x equals 10 and we're asked to solve for x. How should we do it? Well, we know we simply quote-unquote transpose the number 2 to the other side, so we have x equals 10 divided by 2, which is equal to 5. In other words, we divide both sides by 2. But what we are actually doing is multiplying both sides by the multiplicative inverse of 2. That is, the number that when we multiply to 2 produces 1. Therefore, the solution is actually x equals the multiplicative inverse of 2 multiplied by 10. Now, extending this to matrices, we have the following. Ax equals y, and therefore the solution x should be the multiplicative inverse of a multiplied by y. But here, A has to be a square matrix and should have an inverse, because not all matrices will have an inverse. So how do we know if it has an inverse? Well, the determinant has to be non-zero. Wow, okay. How do we get the determinant? Well, in Excel, we simply use mdeterm, that function in Excel. However, for most problems that are encountered in real life, the matrix will have an inverse, especially when talking about what's called the variance-covariance matrix. More about that in the future. So going back to our beginning problem, we had these equations. And it should be clear that these 3 equations and 3 unknowns can be written in matrix notation as follows. So for example, the first line, which is 2x plus y minus z, is exactly the multiplication of the first row and the first column of A and B respectively. Therefore, we have this. This can be written as ax equals y, and therefore the solution is x equals A inverse times y, which means we need to get an inverse of A and multiply it to y, taking care that we do the multiplication in the proper order of operations. The inverse comes out to be this. So if we multiply A inverse by y, we will get x, and the solution happens to be the column vector 2, 3, negative 1. which means the solution is x equals 2, y equals 3, and z equals -1. So that's all that we have for today. Kindly like and share and subscribe for more of this linear algebra lessons that are coming your way. Bye for now.